So students, now we have come to the last portion of alcohol, and after completing these conversion questions of alcohol, we go to the phenol, the last topic of the chapter. So in the syllabus, it is mentioned that you have to convert one alcohol to another alcohol, which is very important, as I mentioned here. So let us see the first conversion, how to convert methyl alcohol to ethyl alcohol. You have to convert methyl alcohol to ethyl alcohol, methyl alcohol to ethyl alcohol. The question may say convert methyl alcohol to ethyl alcohol, or such question may come in ABCD reaction form. How? I will let you know later. And methyl alcohol IUPAC name is methanol. Do remember OL means alcohol and ethyl alcohol IUPAC name is ethanol. So first you have to make the picture of both. So let me make first. So methyl alcohol formula is CH3OH. This is called methyl alcohol. Okay, CH3OH is methyl alcohol. And ethyl alcohol formula is somewhere here. CH3CH2 means ethyl, OH means alcohol. So this is your methyl alcohol, this is your ethyl alcohol. So you have to convert methyl alcohol to ethyl alcohol. Now if you observe properly, what you observe here is in methyl alcohol there is one carbon, whereas in ethyl alcohol there are two carbon. Methyl alcohol has one carbon, ethyl alcohol has two carbon. That means you came to know that you have to increase carbon from here to here, right? You have to increase one carbon number. That is your first task. Methyl has one carbon, ethyl has two carbon, you have to increase one carbon. So to increase carbon, always you remember, if it is alcohol, put PCl5 first, followed by KCl. So these are the two things we are going to use. You came to know in methyl alcohol there is one carbon, and ethyl alcohol there are two carbon. So whenever you want to increase carbon from alcohol, you have to put PCl5 and KCl. Do remember, it's a trick. Now see what happens. When you put PCl5, you know that the function of PCl5, I have said you can write it like this. This is PCl3, ClCl, and this H will go with Cl to form byproduct as HCl. This O goes with PCl3 to form byproduct as POCl3, known by the name phosphorus oxychloride. Now what is left here is methyl, and what is left here is one chlorine, so we get methyl chloride. Now into this methyl chloride, when you put KCN, this K and Cl goes out to form KCl. K and Cl will go out to form KCl. Now what is left here is methyl, and from here what will come is cyanide. So what we get here is methyl, CN means cyanide. So we got methyl cyanide, students. Now you can see here it was one carbon. Now how many carbon you see here? Two carbon. This compound is called methyl cyanide. And do remember, in organic chemistry, cyanide is also known by the name nitrile. Cyanide is also known by the name nitrile. So methyl alcohol, when you put PCl5, OH gets removed, Cl gets enter, you get methyl chloride. And when you put KCN, KCl goes out, you get methyl cyanide. So here was one carbon, so here is two carbon. So I increased one carbon from alcohol by reacting with PCl5 and KCl. Now I need to convert this cyanide to alcohol. So to remember one thing, students, here you are going to put reducing agent like lithium ammonium hydride. Lithium ammonium hydride is a reducing agent which produces 4 nascent hydrogen. Okay, lithium ammonium hydride is a reducing agent which produces 4 nascent hydrogen, out of which 2 will go to carbon, 2 will go to nitrogen. Now see what I have done here. This lithium ammonium hydride produces 4 nascent hydrogen. Out of 4 nascent hydrogen, you put 2 out here to get CH2, put 2 out here to get NH2. And what you got here is ethylamine. The name of this compound is ethylamine. Now once I got amine, my next task is to convert it to alcohol. Ethylamine to ethyl alcohol. I have taught you in the preparation of alcohol. This one, amine to alcohol. So we can convert amine to alcohol by adding nitrous acid. We can convert amine to alcohol by adding nitrous acid. HNO3 is called nitrous acid, which we write by like this, O no. How to write nitrous acid? O no. So when you split this nitrous acid this way, it is HNO2 only, no? HNO, when you split like this ethyl will take this OH and forms ethyl alcohol. This nitrogen and this nitrogen combines to form N2. Minus means goes out, and this H2 combines with this O to form water, which is also out. So ethyl alcohol we get here, N and N combines to form N2, H2 and O combines to form water. So this is how we convert methyl alcohol to ethyl alcohol. So first I increase the carbon by putting PCl5 and KCN to alcohol. Then I use reducing agent. So 2,2H entered here to form amine. And once you get amine, you do nitrous acid, you put, where amine will convert to alcohol, students. So this is one conversion, methyl to ethyl. Now we go opposite. You can take the screenshot to make the notes. Now we go opposite. Now you have to convert ethyl alcohol to methyl alcohol. Ethyl alcohol is known by the name ethanol. Methyl alcohol is known by the name methanol. To do this conversion, students, okay, we'll make the formula first. CH3 CH2OH. This is ethyl alcohol, and my job is to convert it to methyl alcohol. Ethyl alcohol to methyl alcohol. Now if you see out here, from this alcohol to this alcohol, when you have to convert, you came to know here is 2 carbon, here is 1 carbon. That means my job is to reduce carbon number. From 2 I have to reduce it to 1. To do so, first you do oxidation. To do so, you do first oxidation. Ethanol on oxidation gives you ethanol, general oxidation trend. Ethanol again on oxidation gives ethanoic acid. Property number 7 of alcohol chapter. Ethyl alcohol is also known by the name ethanol. Ethanol on oxidation gives ethanol. Ethanol on oxidation gives ethanoic acid. And our oxidizing agent to be used, I have said you, is K2Cr2O7 plus conc sulfuric acid. Here also you'll put the same oxidizing agent K2Cr2O7 plus concentrated sulfuric acid. Same oxidizing agent. And alcohol is linked with CH2. It's primary alcohol. So primary alcohol on oxidation gives aldehyde. Al means aldehyde. If it was secondary alcohol, on oxidation it could have given ketone, but it's primary, so it gives aldehyde, and the byproduct out here will be water. In this case, no byproduct. I've explained you earlier. Now we got ethanol. Now the formula. Al means aldehyde, right? CHO. And it means 2 carbon, 1 carbon is here. So you add CH3. This is the formula of ethanol. Now ethanoic acid means again there is acid, put COH. And it means 2 carbon, 1 carbon is already here. So you will add CH3 to make 2 carbon. So ethanol on oxidation give ethanoic acid. So whenever you have to reduce carbon number, first you do oxidation of alcohol 2 times to make it acid. Once it becomes acid, students, now remember the class 10 property. Whenever acid reacts with base, we get salt and water. Acid base gives salt and water. So this H will go with this OH. H and OH will give you water out. H2O, water out. Now what is left here? CH3COO is left. From here we will come Na. And this is the salt form, and the name of this salt is sodium acetate. Now once you get sodium acetate, students, to this sodium acetate, you are going to put soda lime, and you are going to heat. You add soda lime and you will heat. Okay, once you get this, you put soda lime and you will heat. Soda lime actually is a mixture of NaOH and CaO. Soda means NaOH, lime means CaO. In this reaction, this is not acting as catalyst. Calcium oxide, okay, helps sodium hydroxide not to liquefy. Actually, our sodium hydroxide is a deliquescent substance which readily liquefies. To prevent its liquefaction, we add calcium oxide. But in this reaction, only sodium hydroxide will react with this, not calcium oxide. So when you do so, only this portion is going to react with this. So this much portion from here of sodium acetate goes out with this much. As a result, what will happen? See out here. Na2CO3 will come out. That means sodium carbonate will come out. Na2CO3 will come out. Now here is what is left. CH3 is left here. And here what is left? H. So this CH3 and H combines to form CH4. CH3 and H combines to form CH4, which is your methane. Now we proudly reduce 1 carbon. Here was 2 carbon. I reduce it to 1 carbon. So always remember, whenever you have to increase carbon number from alcohol, put PCl5 and KCN. Whenever you have to decrease carbon number, you have to oxidize alcohol first to the acid, then make the salt of acid, then put soda lime, whereby carbon will reduce. Now how to convert methane to methanol? So if you see out here, when you convert methane to methanol, that is methyl alcohol, methane to methanol, that is methyl alcohol, here is CH4, here is also CH4, CH4, CH4 in total. Here is no oxygen, but here is one oxygen. That means I had to add one oxygen. So to add oxygen is called oxidation. So I have to do oxidation of methane. So when I oxidize methane, then CH3OH will give you methyl alcohol. So methane on oxidation gives methanol. But who is our oxidizing agent here? K2Cr2O7 plus concentrated sulfuric acid. When you add, methane will convert to methanol, students. So this is all about the conversion of methanol to ethyl, ethyl to methyl. Now how the question may come from here? They may say like this: methyl alcohol on reaction with PCl5 gives A on reaction with KCl gives B, okay, gives B on reaction with lithium aluminide gives C on reaction with nitrous acid gives D. Who is D? Identify. 4 option. It will come in MCQ. So answer is ethyl alcohol. But how you land up to this answer? You have to do this much drop work. Similarly, here the question may come this way, students. Ethanol on oxidation gives A, which on oxidation gives B, which on reaction with NaOH gives C on reaction with soda limes gives D, and D on oxidation gives E. Identify E. So you have to do the rough work again of this much, and you land up the answer as methanol. These two are very important reaction, so you have to learn and you have to practice, students. Now the next important conversion, students. Okay, it is very important conversion which way I am going to start with you all now. Conversion of primary alcohol to secondary alcohol to tertiary alcohol. 1 means primary, 2 means secondary, 3 means tertiary. So how to convert primary alcohol to secondary alcohol to tertiary alcohol? So let us take one example of primary alcohol as ethyl alcohol. So I am taking the example of primary alcohol as ethyl alcohol. Okay, students? Ethyl alcohol is also known by the name ethanol. So I am taking this as the example of primary alcohol. Now this is your OH link with CH2 primary alcohol. Now I have to convert it to secondary and tertiary. How I can do so? So first of all, if you see alcohol, you oxidized. And you know our oxidizing agent is K2Cr2O7 plus concentrated sulfuric acid is your oxidizing agent. And ethanol on oxidation gives ethanol. Ethanol on oxidation gives ethanol. Why ethanol? Primary alcohol on oxidation gives aldehyde. Al means aldehyde. If it was secondary alcohol on oxidation, it would have given you ketone. Okay. Now, formula of this: aldehyde means CHO, and eth means 2 carbon, 1 carbon is here. So put CH3 to make 2 carbon. So you got ethanol. This compound is also known by the name acetaldehyde. Okay. Common name is acetaldehyde. IUPAC name is ethanol. Common name is ethyl alcohol. IUPAC name is ethanol. And when you do so, the byproduct out here will be water, students. You can see here is 2 carbon, here is 2 carbon, here is 1 O, here is 1 O, here is 6H, but here is only 4. So 2H from you takes this O2 from water. So I converted primary alcohol, that is ethyl alcohol, I started with, and I converted it to ethanol, that is acetaldehyde. Now to this you add Grignard reagent. We have learned that reaction, CH3MgI. And when you react with Grignard reagent, the second step has to be acid. H plus means acid, hydrolysis. When you do so, students, first you write this as it is. CH3CH. You can see I wrote this CH3 here, then this CH here. Now drop this O down. It will not die. CH3CH, this O is down. Now this CH3 of Grignard reagent, take it to the C part. And you know that water means HNOH. So this H of water, take it out here. Now what is left in water? OH is left. What is left in Grignard reagent? RMgX. Mg and I is left. So that will surround this compound, and this is called magnesium hydroxyl iodide. Magnesium hydroxyl iodide, which is a byproduct, minus. So we got this one. Now you can see here OH is linked with CH. OH linked with CH is called secondary alcohol. So I converted primary to secondary so far. Now the name of this CH3OH is called isopropyl alcohol. The name of this compound is isopropyl alcohol, also known by the name sec-propyl, because it is secondary alcohol, right? So we even call it by the name sec-propyl alcohol. Secondary alcohol, sec-propyl alcohol, students. And the IUPAC name of this, you can see there are 3 carbon, right? Prop, single bond, so N, alcohol in number 2 position, so propanol 2 is just ipecaine. So by this I converted 1 degree to 2 degree, but my task is to make it 3 degree also, right? Now again you are going to oxidize this. Okay, now again our oxidizing agent is K2Cr2O7 plus concentrated sulfuric acid, oxidizing agent. And when primary alcohol gets oxidized, you get aldehyde, but this is secondary alcohol. Primary alcohol on oxidation gives aldehyde. Secondary alcohol on oxidation gives ketone. So here we get ketone, and the name of that ketone which we get out here is acetone. Just remove this 2H. So what we get here? CH3, CO is left, and here we get CH3. This is the formula of acetone. Now CH3, CO, CH3, this 2H which has been removed goes with this O to form water. H2O, water out. And this CO single bond will become double bond. And we get acetone, which is a ketone, students. Okay, which is a ketone. So always remember, primary alcohol on oxidation gives aldehyde. Secondary alcohol on oxidation gives ketone. Byproduct will be water. When you oxidize, byproduct will be water. So we land up to the ketone. Now I have to make a tertiary alcohol, so use Grignard reagent one more time. You're going to use Grignard reagent one more time. And here I'm going to add again RMGX. R is methyl here. Number 1. Number 2, you do acid hydrolysis like before when you react with Grignard reagent. So when you do so, students, out here, what will happen now? First, write this thing same as it is. CH3, C, CH3, single bond O. Double bond O, make it single bond O. Okay. Now, this Grignard reagent CH3, you take it out here to the C. And from water, you know water can be written as H and OH. So take water H out here towards O. Now what is left here? OH. That goes with MgI from here. And the byproduct out here will be MgOHI, which is known by the name magnesium hydroxyl iodide. If you have taken here chlorine, you could have got magnesium hydroxyl chloride. If you have taken bromine, you could have got here magnesium hydroxyl bromide. Same thing. Now if you see here, OH is linked with C. OH linked with C. OH linked with C is referred as tertiary alcohol. And the name of this is T-butyl alcohol. T means tertiary. There are 4 carbon, 1, 2, 3, 4. T-butyl alcohol we call it as. Okay, we call it by the name T-butyl alcohol. So if you see this process, students, I have converted. You can take the screenshot of this. You can take the screenshot of this, students. I hope you have taken so. Now look out here. So I converted primary alcohol to secondary alcohol and finally to the tertiary alcohol. Such a long reaction, but the question will come in fragments. For example, I'll give you one question. Pay attention. But how to remember this first? How to know that how to convert primary to secondary, secondary to tertiary alcohol? You start from ethyl alcohol. I have already said you. Whenever you want to convert primary to secondary to tertiary, you start from ethyl alcohol. And the trick is oxidize, then do Grignard. Oxidize, again Grignard. So what is the trick? So this is how you're going to remember. Whenever you have to convert primary to secondary to tertiary alcohol, take ethyl alcohol and start from there. And first you oxidize, put Grignard reagent. Oxidize, put Grignard reagent. Oxidize, Grignard, oxidize, Grignard. Now let us see how the question comes from here. Okay, the question may say you convert ethyl alcohol to isopropyl alcohol. So from here to here is the answer. Convert isopropyl alcohol to T-butyl alcohol. From here to here is the answer. Convert acetaldehyde to acetone. From here to here is the answer. Convert ethyl alcohol to T-butyl alcohol. The whole reaction is the answer. Convert acetone to T-butyl alcohol. From here to here is the answer. Convert acetaldehyde to isopropyl alcohol. From here to here is the answer. So many questions. From this single reaction, I can fragment this into 20 small reactions. So students, do learn this reaction properly. So by this, we come to the end of conversion of alcohol, and we come to the end of alcohol topic. So we have finished ether, we have finished alcohol. From next class, we will start phenol, the last portion of the chapter called ether alcohol phenol, and the last portion of your first sem syllabus. Thank you very much.